Okay. All right, so we're just going to do an example. So let's just write down, find the first and second derivatives. Find and then this is a fraction, so I'm just writing the denominator first. Okay, now guys, at first glance, it might look like we just need to use quotient rule, all right? Which isn't necessarily that bad. It's just that in our denominator, we're gonna have to use product rule as well. So this would be like a combination between quotient rule and product rule. And these are quite easy. The numerator is quite simple, and the denominator, it might not always be like that. Okay, so I just want us to go over the process of doing partial fractions, because if we could split this up into two separate fractions and then just do it, you'll see they actually are much simpler. All right, but we need to actually know how to do the whole partial fraction scenario from there. Now, guys, usually you would get a fraction and you would first have to factorize the denominator. In this case, the denominator has already been factorized. Okay, so I'm just going to write here, break the fraction up into its partial fractions. Now, when did we do partial fractions? Like in which year? Can you remember? Grade 10. Okay. So it has been a while. All right. So just a reminder, this you would write. So you would say x over x minus 2 times x plus 2. And then you're going to split it up into, because we have two factors here. If you had 3 brackets, you would do three separate ones. We're going to split it up into a over the first factor, which is x minus 2, so the first bracket, plus, and that might turn into a negative. It depends on what the value of b is. All right, but we just go with a plus for now. B over x plus 2. All right, do you remember that step? And now we're going to, can anyone remember what comes next? Multiply through by the LCD, hey? So the LCD is this original denominator, x minus 2, x plus 2. So I'm just going to write that on the side. We're going to times by the LCD, which is x minus 2, x plus 2. Now, if I multiply the first fraction by that LCD, the denominator is obviously going to cancel out. So I'm just going to be left with x. That is equal to the next fraction. I'm going to have a, and the x minus 2's are going to cancel out. So I'm going to have a times x plus 2, right? Because I'm multiplying that by x minus 2, x plus 2, and then plus b. Now the x plus 2's are going to cancel out. So just the x minus 2 is going to be left. All right, then we're just going to multiply out that right-hand side. So we're going to have ax plus 2a plus bx minus 2b. I'll just rewrite that x. You don't have to rewrite it. Can anyone remember what we do next? We group them, hey? Yeah, good. So we're going to group the x terms, and then we're going to group these will represent our constant terms. Okay, they have no x's. So we're going to just take x out as a common factor here, and what is left if I group the x terms, it's ax plus bx, so I'm going to be left with a plus b, and then plus, now I'm just going to put brackets around the next two just to kind of group them together, but you don't really have to. You can. Okay. Now, guys, we're going to compare, all right? What is the coefficient of x on the left-hand side? 1. What is the coefficient of x on the right-hand side? Well, the a plus b, essentially, all right? So you could write it in front. So this coefficient of x, because we're saying that this is an equation, we're saying that the left-hand side is equal to the right-hand side. The number here, remember number, we don't know what a and b are, there will be numbers. The number here should be equal to the number attached to x on the other side in front of x. All right, so now we're going to say therefore a plus b should be equal to 1. And then guys, what is my constant term on the left hand side? 0. So the constant term on the right, which is 2a minus 2b, should be equal to the constant term on the left, which is just 0 in this case. Now we're going to solve that simultaneously. All right, is it fine if I make a the subject here? Again, here from here on, it doesn't actually matter what your steps are as long as you are able to solve them. So I'm saying that a is 1 minus b. So then I'm going to sub that in here. Right, I'm going to multiply out. So we get 2 minus 2b minus 2b is equal to 0. So we end up with negative 4b is equal to negative 2. So b is then a half. Then we're going to take that b into the other side. So therefore, a is then 1 minus a half, which is also a half. Therefore, our function f of x can also be written like this. If a is a half, then I can write it as 1 over 2 bracket x minus 2. Or remember, we're going to have to, okay, let me do that first, actually. Let me not get ahead of myself here. All right, that would be the first term. And then we do the same with the second term. So plus b is also a half. So I'm going to write it as 1 over 2 times x plus 2. Remember, guys, what was the purpose of this question actually? Not to just work with partial fractions, but to find the first and second derivatives of this function. All right, now here, I can rewrite this as a half x minus 2 to the negative 1. Then it's quite easy to derive, to find the derivative of that. Right? Instead of now trying to use quotient rule for this. Plus, we can do the same with the next fraction, a half times x plus 2 to the negative 1. Okay, guys, please find the first and second derivatives of this function for me on your own. So of each of those terms. Okay, there we go. What I got. No, you don't have to show that one. I just showed it there to remind you that you would have to actually multiply it by the derivative of the inner function. Okay, it should be fine to leave it like that. Yeah, I'm just showing you the other option. Just check if you want me to go over any of those steps. I do want to go back up to the partial fractions bit just quickly. Okay, I don't know if you guys remember, but in certain cases, there is a way of doing the partial fractions bit where you just let x equal to a specific number and then you sub it in, then it's much quicker. So I wanted to show you guys the long method because that is what you're going to have to use in most cases, all right? But when you have linear factors like this, just an x minus 2 and an x plus 2, not an x squared, not a bracket squared, just a bracket times a bracket, and they are both linear, then what you can do is once you have this line over here, and let me add that as a note. Linear factors. Then let x equal each of the roots of the denominators. I'll show you now what I mean by that. Well, I suppose you could say each of the roots of the factors as well. The denominators, the factors, they're the same thing in this case. Okay, so if we're looking at our two denominators, our two factors, if I'm saying that we're letting x equal to each of the roots, then I mean that if we make this denominator equal to 0, so x minus 2 equal to 0, what would our x value be? If x minus 2 is equal to 0, then x is positive 2, right? We could also call them the critical values of the denominators, if that makes more sense, all right? So then you're going to sub this into this line, right? So you're going to say 2 equals a times 2 plus 2 plus b times 2 minus 2, sorry. So this whole term is actually going to go away. Sorry, not x, you make that x. Sorry, let me actually just write it down. And I'll just write it down properly. So you're going to sub in both of these, x plus 2 equals 0. So you're going to get x equals negative 2. All right, those are the two values that you're going to sub in. Then sub into this line. Is it fine if I just say this line because I have put an arrow there? But we're going to sub it into the right-hand side of that. No, guys, sorry, I'm talking nonsense. Not the right-hand side. Sorry, because I was thinking I was solving for x. We're solving for a. Sorry. I'm still asleep. Okay, sub into this line. So then if you're subbing in x equals 2, into this line, you're going to say 2 equals a times 2 plus 2. And what's going to happen with the b term, if you make x equals 2, it's going to be 2 minus 0. So the b term is going to go away. All right, and remember, what are we solving for? We're trying to find the a and the b values. So here we have 2 is equal to 4a. So if I then solve for a from there, 2 equals 4a, then I'm going to get that a is equal to 2 over 4, which is a half. Right, I will go through that again because I'm sure I confused you guys now a bit. Okay, but that is what you get when you sub in x equals 2. You actually get the a value straight away. Then if we sub in x equals -2 into the same line, then we have x is -2, so you say -2 is equal to, and now the a term is going to become 0 because now you have -2 plus 2 is 0 times a is just 0. Then you're going to have b or plus b. You can say 0 plus b, it doesn't really matter. -2 minus 2. So that leaves me with -2 is equal to -4b, which if I now solve for b again, it's going to be -2 divided by -4. So b will also equal a half. Okay, sorry, I'm going to repeat that. Okay, if you are working with partial fractions and you have only linear factors, so this won't work if you have an x squared or an x cubed or a bracket squared or a bracket cubed, whatever. It's literally just linear factors. Then you still need to split it up into the separate fractions, and you still need to multiply through by the LCD to get this line. Then from there, you're going to find the roots of the denominators or the critical values of the denominators. All right, so if you were to make them equal to 0, then you would get these two x values. Then those two x values are going to sub into this line, right? Both sides of the line, sorry, of this equation, not only the one side, because we're trying to solve for a and for b. Then once you've subbed them in, you're just going to get those actual values. But guys, it is quite good to actually just know this method as well, because this method is quite limited in the sense that it only works if you have linear factors, where this method will work for any type of partial fraction scenario. And I mean, it's up to you guys. Now, if you are using this method, the only thing that you actually need to write down is you need to go to that line, and then you're going to write x equals 2, and you're going to show your substitution, you're going to show your answer. Then you're going to say x equals -2, you're going to show your substitution and show your answer. So it will be a bit less writing. So yeah, it is up to you guys which method you want to use. Some of you might prefer to just know one method and use that method always. That's also, yeah. Okay, guys, you're just going to practice some of these. So I'm going to give you exercise 15.11. which is on page 172. And it's just 4 of these, all right? So you're doing the partial fractions and then you're doing the derivatives. Then I'm just going to not really set it as homework, but I will do it and I will show you, or I will post the answers if you want. It's from the old textbook. I'll post it in on the group now, but it's just another one with some higher order derivatives with different derivatives mixed together. So you might want to practice those. So I will post it on the group just now. It's exercise 4.2, which is on page 38 and just number 1. And I'll take a picture of that just now and show it to you guys. Guys, have I actually given you the PDF version of the old textbook? Is it on Classroom? Have I not done that? Let me just quickly check. I think I have it saved on here.